Frontier AI models are now uncovering software vulnerabilities at a pace that human maintainers simply cannot keep up with. When AI speeds up how quickly bugs are found, the manual work of writing and testing fixes becomes the primary delay in a security pipeline. The Codex Security plugin aims to automate this entire remediation process. To follow along with this workflow, you will need the Codex Security plugin installed in your IDE and access to a vulnerable test repository. Integrating AI into the remediation loop allows security teams to address these vulnerabilities at a scale that matches the speed of modern discovery. Before scanning any code, we have to address access. OpenAI employs automated safety classifiers that monitor API traffic for suspicious cyber activity to prevent misuse. Legitimate security research can trigger these monitors. If the system flags your activity, your requests are silently rerouted to a less capable model, and you will see a warning notice like this in your terminal. To maintain access to specialized cyber models, you must verify your identity to register for Trusted Access for Cyber. This ensures that your defensive work is not blocked by the automated classifiers. Once verified, you can check your API logs to confirm you have access to models designed for complex security analysis, such as GPT 5.3 Codex and GPT 5.5 Cyber. With your access confirmed, open the Codex Security plugin and initiate a deep scan on your vulnerable repository. The AI analyzes the codebase, triages findings from existing scanners, and maps the architecture to build a comprehensive threat model. From that model, the system traces specific attack paths. This diagram shows how the AI maps the exact flow of data from an external entry point through various software layers and down to the vulnerable core function. This deep scan transforms a complex codebase into a clearly mapped and understandable threat landscape. GPT 5.5-Cyber evaluates reachability. This logic tree separates theoretical bugs from truly exploitable threats. By isolating the reachable path, it provides validation evidence, demonstrating an attacker can actually execute the vulnerable code in this environment. Once the vulnerability is validated, select the Generate Patch action to begin the remediation phase. The AI instantly writes a fix specific to your codebase. As shown in this code diff, the vulnerable red code on the left is replaced by the AI's secure green code on the right. This workflow keeps a human in the loop. You must review the AI's guidance and run local test suites to verify the fix works as intended without affecting other functionalities. After the tests are successful, you can merge the validated fix into your production branch. Finally, you can export these findings into Sarif and CodeQL formats. This allows you to feed the remediation data directly into your enterprise vulnerability management pipeline. Verifying reachability and automating the patch generation process allows developers to resolve security risks without manually investigating every finding. This workflow is currently being applied to secure the critical infrastructure of the open source ecosystem through the Patch the Planet initiative. Many open source maintainers are currently overwhelmed by a surge of low-quality AI-generated bug reports that require significant manual triage. This flowchart shows the Patch the Planet solution. AI discovers the issues, but in Step 2, expert researchers validate the findings and the patches. This ensures the maintainer in Step 3 receives a fully tested, ready-to-merge fix. In a 5-day trial, a team used this system to uncover hundreds of flaws and successfully merged dozens of patches into widely used projects like curl and Go. Filtering AI-generated findings through expert validation provides project maintainers with the support they need to secure shared infrastructure without increasing their administrative workload. We have moved from analyzing raw source code to exporting a verified, tested patch directly into a security pipeline. The tools used in this tutorial are the same resources currently protecting global open source infrastructure. Enterprise defenders can request trusted access for their teams through an OpenAI representative to maintain high-capability model access for their security operations. Open source maintainers can apply for the Codex for Open Source program to gain access to these automated remediation tools for their own projects. As AI accelerates how quickly vulnerabilities are identified, the focus of defense shifts to using these exact same models to patch the planet.